You know, Gio, I have to hand it to humans. When it comes to building things, they sure do a good job. From city skyscrapers to household tools to the wheels on our car, they've built quite an exciting and interesting world. But I was wondering, how did humans learn to make these things? And what are they all made from anyway?
Well, Iggy, humans learned a long time ago that the best place to look for materials to make tools and shelter was within the earth. That's where they found useful and amazing rocks and minerals that they used to create so many wonderful things, from pyramids to rockets, not to mention you and me.
You're telling me I'm made out of rocks? No way!
Actually, the minerals that make up rocks are what make you so special. But that's just part of the story. What do you say we hook up our databanks and examine our files on rocks and minerals? Rocks are made up of a mixture of minerals.
But what are minerals?
Well, Iggy, minerals are solid, pure substances found in the earth. They are not made by humans, but by processes deep within the earth. Every mineral has special qualities called properties. Minerals are structured in special patterns called crystals. Some are block-like, while others take pyramid shapes. These patterns help us tell the difference between minerals. Look at these two minerals. Both are made from exactly the same thing, carbon. But their crystals make different patterns. That's one way we know they're different minerals. Here is a beautiful diamond, and this is graphite, which is used to make pencils.
But how are these crystals made?
Well, the best way to answer that is to take a look at how one type of crystal can form.
Crystals are made whenever a liquid slowly turns into a solid. Take water and ice, for example. Water is a liquid. When water gets cold enough, solid ice crystals begin to form. Many mineral crystals form when super hot melted rock cools and hardens. For example, quartz, the most common mineral, often forms in this way. But freezing or cooling isn't the only way solid crystals can form. Crystals can be deposited or left behind by a liquid when it evaporates or dries. That's the case with salt water. The salt is mixed into or dissolved in the water. However, when the water evaporates or dries up, the salt forms solid crystals. Today, we're going to create solid crystals from a liquid. We're going to make rock candy. For this experiment, you'll need an adult to help you do some of the work. You'll also need a hot plate, a large saucepan, a wooden stirring spoon, and a candy thermometer. You'll also need about 250 milliliters or 1 cup of water, around 600 grams or 2½ cups of white granulated sugar, a large jar, some yarn, a wooden coffee stirrer, and a pad and pencil. First, pour the water into a large saucepan, then mix in the sugar. Have an adult heat the mixture, stirring it until the sugar is completely dissolved. At this point, the adult should stop stirring. Your group should keep heating the mixture until the candy thermometer shows it has reached 125 degrees Celsius or 260 degrees Fahrenheit. Next, have the adult slowly and carefully pour the hot liquid into the jar. Now, tie the yarn to the center of the coffee stirrer. Place the stirrer across the top of the jar. Make sure that the yarn hangs down into the sugar mixture. Then your group should carefully set the jar aside to cool. What do you think will happen in the jar after the mixture cools? Write down what you expect to happen. Now let the jar sit undisturbed for about 7 days. When you return to your jar, you should see that quite a change has taken place. Write down what you see. You should see that large crystals of rock candy have grown on the yarn in the jar. How did this happen? As you saw, the sugar dissolved easily in the heated water. But as the water cooled, the sugar became crystals again. It recrystallized. As the mixture cooled and time passed, the extra sugar collected on the yarn as solid crystals of rock candy. More crystals formed as time passed. Though the yarn is the best place for crystals to form, you may also see crystals of sugar on other parts of the jar. In fact, if enough time passed and all the water evaporated from the jar, all of the sugar would be left behind as crystals. Remember, this was only a demonstration of one way crystals form, and we made rock candy, which is definitely not a mineral.
So, Geo, besides looking at crystal shapes, how can I tell minerals apart?
For one thing, scientists look at how minerals break apart. Each mineral usually makes its own shape and pattern when it breaks. The way a mineral breaks is called cleavage.
Hey, the cracks follow the shapes of the crystals.
Exactly! There's another way scientists tell minerals apart. Take a look at this piece of topaz and this talc. What do you see that helps you tell them apart?
That's easy. They're different colors.
You're getting the hang of it. Color is another property of minerals. Now look at these two minerals. One is quartz and the other is a diamond. See any differences between the two?
Well, one is shinier than the other.
Good! Shine or luster is another property of minerals. The diamond has more luster than the quartz. Another way to tell minerals apart is by testing how hard they are. Diamonds are the hardest and can scratch any other mineral. Talc is the softest, so all the other minerals can scratch it. All these different properties of minerals determine how people can use them.
Well, I know that humans like to wear diamonds as jewelry, but do they have any other uses?
Actually, Iggy, I'm going to need a little help on that. My files aren't complete.
Then let's call up the Kids Into Doing Science Club for more information.
Hello, Kids Into Doing Science. This is Michael. How may I help you?
Hello, Michael. It's Iggy and Geo. Could you tell us about some other uses of diamonds besides jewelry?
Sure, I can get that information. Here we go. As you may know, a diamond is the hardest mineral that exists.
Yes, and this property means that it can scratch glass.
And even cut it.
Are you telling me that this saw is made of diamonds?
Close. Its steel blade is coated with diamond dust so it can cut through solid steel.
Sounds like a pretty expensive saw.
Diamonds are also used to make tools and for computer parts.
Thank you, Michael. That was very helpful.
You're welcome. Talk to you soon.
Iggy, diamonds aren't the only minerals that are useful. Iron is used to make steel.
Oh, like the steel frame inside me and the steel that makes your body.
Exactly. And speaking of bodies, some minerals are even important to the human body.
Next, you're going to tell me that people eat minerals.
Actually, they do. People eat minerals that are found naturally in the foods they eat, such as the iron found in spinach. Plants like spinach soak up minerals from the soil through their roots. Soil is made up of broken down rocks.
Wait a minute. Rocks? Soil is made of rocks? I'm a little confused, Geo. What does this have to do with minerals?
Iggy, rock is what makes up the part of the earth we live on, the crust. The sand of the hot desert, the cool mountains,
Dark caves. Even the Grand Canyon are all made of rock.
no matter where you go on earth, there's rock under you, from under city streets to country farms. People have lived in rock caves and used rocks for buildings for many, many years. In fact, the reason many ancient statues and buildings have lasted until now is because they were made from strong natural rock. There are many different kinds of rocks, but they all have some important things in common. First and foremost, Rocks are all made of minerals, and different combinations of minerals make different kinds of rocks. Iggy, what do you think happens when nature mixes a few minerals together?
Well, based on what you just said, I'd say that nature is following a recipe for making rocks.
Yes, it's like when you follow a recipe to make cookies. By changing the ingredients you mix into the dough, you get different kinds of cookies.
I see. Different minerals mixed together make different kinds of rocks.
Very good. Let's take a look at how this happens in nature. Pretend we're in Earth's kitchen, deep within the Earth.
Oh, wow, it's hot in here.
We'll mix together minerals such as quartz, feldspar, and mica. Pack it all together, and in 1,000 years, we've made granite. Just one of the thousands of types of rocks you can find on the Earth. With so many different kinds of rocks, scientists have come up with a way to group them into 3 main types based on how they were made. Igneous rocks are made under the Earth's crust when melted rock cools and hardens. You could think of the Earth as a big ball filled with really hot melted rock.
Melted rock? I've heard about that before. Doesn't it have something to do with volcanoes?
Yes, and when some of the melted rock pushes to the surface,
Voila! Igneous rocks!
the second type of rock is made at the Earth's surface from tiny bits of rock and other matter called sediment that get pressed together. Sediment, like sand, sinks to the bottom of oceans and lakes.
Like sugar sinks to the bottom of a glass of lemonade.
Kind of. And over a long time, more and more sediment piles up on top of each other in layers. And all this weight pressing down over a very long time makes the lower layers harden into what we call sedimentary rocks. Take a look. Do you know what this child is writing with?
It's chalk. Are you trying to tell me that chalk is a sedimentary rock?
Yes, exactly. Chalk is a form of sedimentary rock called limestone. Limestone is made from tiny bits of shells and bones from ancient animals that sank to the bottom of the ocean long ago.
So that means the bits of animals became sediments, right?
That's right. And then these sediments were buried by other sediments, and the pressure slowly turned them into sedimentary rock.
Got it. That's a pretty amazing story for a simple piece of chalk.
So we've learned about rocks formed from melted minerals,
Igneous rocks.
and about rocks formed by sediments.
Sedimentary rocks.
The third type of rocks are what are known as metamorphic rocks.
I know something about metamorphosis. It's what happens when things change. Like when caterpillars change into butterflies.
Exactly. And when heat and pressure change one kind of rock into another, we call this new rock a metamorphic rock. Take chalk, for example. It's made from limestone, remember? Under high heat and pressure over a very long period of time, chalk changes into marble.
So does that mean people can make marble out of chalk just by heating it up, like in an oven?
No, it doesn't work that way. People can't make it happen. It takes time. It can take thousands or even millions of years for metamorphic rocks to form. Sometimes rocks are buried and crushed by the weight of the rocks above them. Being pressed together so tightly for a long time causes rocks to change. Iggy, now that you've learned how rocks are made, how would you like to see how people make them even more beautiful?
That would be great.
Let's go!
What is this man holding? Is it a piece of wood? Actually, it's a mineral, a beautiful type of quartz known as tiger's eye. Today, we're visiting a lapidary shop where special rocks and minerals called gemstones are cut, polished, and mounted in jewelry. This is Stan McCall. Stan is a lapidarist, an expert at cutting and polishing gemstones. And today, Amber and Michelle have come to watch Stan work, to see firsthand how gemstones are cut and polished to make jewelry. First, Stan draws a small circle on the rough tiger's eye stone. After this is cut on a special saw, the small tiger's eye disc is attached to a stick with a sticky, melted glue. Then the disc is rounded and roughly polished on a grinding wheel. Finally, Stan rubs the gem against the wheel using a special polishing compound. The result is a gorgeous tiger's eye gem suitable for mounting in a necklace or ring. But where do gemstones such as these come from? Most gemstones are formed underground, so mines are a good place to obtain them. This is a small opal mine owned and operated by miner and lapidarist David Burton. And this is how opals appear when they are first taken out of the mine. Opals are created when water, soaking through the ground, deposits minerals into rocks or fossils, such as the fossilized bones and shells you see here. But it takes a little expert polishing to get them to really shine. Here, David polishes a raw opal in just the right way to bring out its highlights. Though each gemstone is different, they all benefit from expert polishing. It's the same for opal, jade, rubies, or even diamonds. And knowing just where to cut a gem or break it along its cleavage is as important as knowing how to polish it. This beautiful crystal ball was made from clear topaz and took more than a year's worth of work to create. So, as we've seen, when it comes to the gemstones that are used to make jewelry, it's important not only to know where to find them, but how to bring out the best in them as well.
Hey, Geo, let's take a moment and double-check my memory banks to make sure I've properly saved everything we've covered so far. I now know a mineral is found in nature, but not made of living things. Plus, each mineral is solid and pure, made of one thing through and through.
Very good. They're also made of crystals, each with its own pattern.
Yes. And I've learned that you can tell minerals apart by their crystals, color, shine or luster, how hard they are, and how they break. That's called cleavage.
And let's not forget that different minerals mixed together make different kinds of rocks: igneous, sedimentary, and metamorphic. Let's try to pull all of this together and discuss what scientists call the rock cycle. The rock cycle is the series of changes rocks go through. Rocks are always changing. The forces of nature, like moving water and wind, wear away at rocks, slowly breaking them down into sediment. You can see this happening when you visit a beach. The waves roll back and forth against the seashore, breaking down the rocks. Over hundreds of years, the pieces are broken down into pebbles and finally into sand.
And I'll bet that some of the sand will sink to the bottom of the ocean, and when placed under pressure for a very long time, will form sedimentary rocks.
Exactly.
And more heat and pressure can change sedimentary rocks into metamorphic rocks.
Right.
So are igneous rocks a part of the cycle too?
Of course. Some rocks or sediments will sink deep enough into the earth to melt again. And that melted rock can...
Oh, I know. It can come back up through volcanoes.
As igneous rocks. You know, Iggy, people have found plenty of ways to use rocks and minerals. For instance, they use metamorphic rocks like marble and igneous rocks like granite to construct large buildings.
Wow, those rocks must be pretty strong.
They are, and rocks can last a long time, too. Since ancient times, people have used rocks for drawing and painting. By crushing certain colored rocks, artists have been able to make beautiful colors to paint with. The ancient Egyptians not only used rocks to paint, they used minerals like gold for beautiful decoration. And long ago, people learned to make tools from rocks and minerals, and some people protected themselves with weapons made from rocks.
After all this, I'll never look at a rock the same way again.
Well, I certainly hope not. Now that you know so much about rocks, maybe we can collect some along our route.
Yeah. And we'll look at their color, shine, and hardness in order to tell them apart.
And by seeing what the rock is made of, maybe we can guess where it fits in the rock cycle.
The rock cycle. That's the way the rocks change and are formed both deep inside the earth and on the surface.
But what are rocks made of?
Well, we know rocks are made of different minerals. Rocks can change, but minerals stay the same.
Excellent, Iggy. That proves you've learned quite a lot today about rocks and minerals.
Thanks, Geo.